Hello everyone. We're going to keep going with factoring. So we did factoring by greatest common factor. And I did a little short video factoring polynomials by GCF. And that's kind of where we're going with this video series. So factoring is a really important mathematical skill. It's worth spending a lot of time on. And the most essential part of factoring polynomials is by GCF. I mean, there's many other techniques, but your go-to should always be factoring a polynomial by finding the greatest common factor. So I'm going to break it down a little bit more than I did in that short video. Factoring polynomials by finding the greatest common factor. I'm just going to say GCF. Okay. Let's get started. So basically what you need to do, let's just make up a quick polynomial here. I always teach by example. Well, not always, but for things like this, definitely. So for example, we could have 5x plus 15. This is a polynomial. How do we want to factor it? Now we'll see why factoring is important as we go through all these videos, but right now we're just going to think about how to factor it. Okay, well, what's common among 5x and 15? Well, is x common? No. Is 5 common? 5 goes into 5, yes, and 5 also goes into 15. So what you say is you say greatest common factor of 5x and 15 equals, well, it's 5. And this is because 5x, well, 5 divides that, right? How do I want to say that? 5 divides 5x, and 15 divided by 5 is 3, so 5 goes into both of them. This is essentially why. Okay, so GCF of 5x and 15 is 5. Therefore, to factor that polynomial, 5x plus 15, what you do is you pull out your greatest common factor to the left, or the right. I'm going to pull it to the left. It's 5 times, well, what's 5x divided by 5? It's just x. What's 15 divided by 5? It's 3. So you pull out the 5 from both terms. And to check your work, that's how you know if you factored it correctly. You double check your work. Distribute 5 into x plus 3. And you should get the original term. What's 5 times x? It's 5x. What's 5 times 3? It's 15. That's our original term. We did it correctly. Example 2. Let's just go all the way here. Let's say we have x to the power of 5, just some bigger exponent, plus, let's say it's 3x to the power of 5, plus 3x to the 3 plus 9x squared plus 9x squared, yeah, plus 18. Something like that. You can kind of see what I'm going for here. Well, now we got to find the greatest common factor of each of these terms in order to factor this using our GCF. So solution. GCF of 3x to the 5. Let's say it's 18x. Just like that. Just change the question a little bit. 3x cubed. 9x squared, 18x. Well, what is common among all these? Well, 3 divides 3, 3 divides 9, and 3 divides 18. So 3 is common. Now, is x in all of these terms? Yes, it is. How many x's? Well, we have x5, x3, x2, and 1. So the greatest degree exponent on x is 1 right here. Therefore, the biggest x that's common is just 1x. So our GCF is 3. Because 3 is in all the terms, and it's 3x because 1x is in each of these terms, at least one. So therefore, you pull 3x out. 3x to the 5 plus 3x cubed plus 9x squared plus 18x. Well, pull 3x out, you get 3x times 3x to the 5 divided by 3x is just x to the 4. This is just the aside work I'm doing. Let me write it out in case anyone's confused by it. 3x to the 5. What I'm doing is I'm dividing it by 3x here. So the 3's cancel, and one of these x's cancels with that x on the bottom. What you end up with is x to the 4. Anyways, keep going. 3x to the 3 divided by 3x, that's x squared. 9x squared divided by 3x is just 3x. 18x divided by 3x. 18 divided by 3 is 6. X divided by x is 1. You just get 6. You can check your work. What you do is you multiply 3x back through, and you should get the original polynomial. Checking your work is really important in math. I hope this makes sense. I hope it's helpful. So that's essentially how you factor polynomials, by finding the GCF. You find the GCF of each term in the polynomial, of all the terms in the polynomial. You pull it out. You can check your work by multiplying it back through. I hope that helps, and thanks for watching.